Imagine standing in the middle of a muddy field in France just hours after bombs have stopped falling and watching an entire military airbase rise from nothing in less than a day. Picture the faces of German engineers who had spent weeks meticulously planning and building their own airfields only to see Allied forces create fully functional runways complete with fuel depots and control towers faster than anyone thought humanly possible. This is not a story of magic or exaggeration, but a tale of revolutionary engineering that changed the course of the Second World War in ways that few people truly understand. When German prisoners of war first witnessed these construction miracles with their own eyes, they refused to believe what they were seeing was real because their military doctrine and engineering training told them such speed was absolutely impossible. The Allies had unlocked something extraordinary that combined American industrial might with British ingenuity and desperate innovation, born from the absolute necessity of winning a war against an enemy that had conquered most of Europe. This is the complete story of how airfield construction became one of the secret weapons that helped defeat Nazi Germany, and how speed itself became a form of military power that the enemy could never match or comprehend. Before we can understand why German engineers found Allied airfield construction so shocking, we must first explore how the Germans themselves approached this essential military task during the war years. The German Luftwaffe had built hundreds of airfields across occupied Europe, following traditional engineering principles that emphasized permanence, durability, and meticulous planning that could take many weeks or even months to complete properly. German military engineers were trained in the finest technical schools in Europe, and they brought to airfield construction the same precision and thoroughness that characterized all aspects of German military preparation. When the Wehrmacht swept across Poland, France, and the Low Countries in the early years of the war, their engineers would follow behind the advancing armies and begin the careful process of surveying land, drainage analysis, soil testing, and foundation, laying that German doctrine required for proper airfield construction. These were not temporary facilities, but permanent installations built to last for years with concrete runways that could handle the heaviest aircraft, poured foundations for hangars and support buildings, drainage systems engineered to prevent flooding and damage, and electrical systems installed with waterproof conduits buried safely underground. The typical German airfield construction project began with detailed surveying that could take several days as engineers mapped elevation changes, identified problem areas, and planned drainage routes with mathematical precision. Once surveying was complete, construction crews would clear the land of all vegetation and obstacles using heavy equipment and manual labor that might require a week or more depending on terrain and size. After clearing came the critical foundation work, where German engineers would excavate soil to proper depths, install drainage pipes and gravel beds, and prepare the ground for concrete or asphalt surfaces that would form the runways and taxiways. The actual pouring and finishing of concrete runways represented another major phase requiring careful mixing, proper curing time, and surface finishing that could take 2 to 3 weeks even with experienced crews working efficiently. Beyond the runways themselves, German airfields required extensive support infrastructure, including hangars for aircraft maintenance, fuel storage facilities that met strict safety standards, barracks, and mess halls for personnel, control towers with proper visibility and communication equipment, and defensive positions, including anti-aircraft gun emplacements and protective revetments for parked aircraft. This complete approach to airfield construction reflected the German military philosophy of thorough preparation and building for sustained operations over long periods rather than temporary expedient solutions. The Germans believed that proper engineering could not be rushed, and that shortcuts would only create problems later, requiring more time and resources to fix than if the work had been done correctly from the start. The Allied approach to airfield construction did not begin as a revolutionary concept, but evolved from desperate necessity during the darkest days of the war when Britain stood alone against Nazi aggression. In the summer of 1940, after the fall of France and the miraculous evacuation at Dunkirk, the Royal Air Force found itself defending Britain against the largest air assault in history during what would become known as the Battle of Britain. German bombers and fighters launched relentless attacks against British airfields attempting to destroy the RAF on the ground, and in the air to achieve the air superiority necessary for a successful invasion of the British Isles. During those terrible months of sustained combat, RAF airfields became prime targets for German bombing raids, and many of the carefully built permanent airfields that Britain had constructed during peacetime were severely damaged or completely destroyed by enemy action. Fighter Command quickly discovered that traditional airfield repair methods were far too slow to keep pace with the damage being inflicted by German attacks, and that waiting days or weeks to repair bomb-damaged runways meant losing precious fighter aircraft that had nowhere to land and rearm during combat operations. This crisis forced British engineers to develop entirely new approaches to airfield construction and repair that prioritized speed above all other considerations, because, in the desperate summer of 1940 time, meant the difference between survival and defeat. The British began experimenting with prefabricated materials, rapid construction techniques, and simplified designs that eliminated unnecessary features in favor of getting aircraft back into the air as quickly as possible after an attack. One of the most important innovations to emerge from this period was the development of specialized rapid runway repair techniques that could fill bomb craters and restore damaged surfaces to operational condition in hours rather than days, using materials and methods that German engineers had never considered for military airfield construction. British engineers also began creating temporary landing strips in fields and open areas, using nothing more than rolled earth matting materials and minimal grading to provide emergency landing sites for damaged aircraft or to disperse fighters away from main airfields that were under heavy attack. These wartime necessities planted the seeds of a construction revolution that would eventually astonish German engineers when they witnessed its full implementation during the Allied liberation of Europe several years later. But in 1940, it was simply about survival and keeping fighters in the air long enough to prevent German invasion. When the United States entered the war in December 1941, after the Japanese attack on Pearl Harbor, the Allied airfield construction effort gained access to something that would prove absolutely decisive in the years ahead, which was American industrial capacity, and engineering innovation on a scale never before seen in human history. American engineers and construction companies brought to the war effort decades of experience in rapid large-scale construction, projects from the building of highways and dams to the development of commercial airports and the construction of entire cities in previously undeveloped areas. The American approach to construction emphasized speed, efficiency, standardization, and the use of machinery and prefabricated materials rather than relying primarily on manual labor and custom solutions for each project, as European traditions often dictated. American military planners recognized immediately that the coming war would require airfields to be built in every theater of operation, from the deserts of North Africa to the jungles of the Pacific, from the frozen wastes of Alaska to the islands of the Mediterranean, and that traditional construction methods would never provide the speed and scale necessary to support the massive air operations that modern warfare demanded. The United States Army Corps of Engineers, along with Navy construction battalions, known as Seabees, began developing standardized airfield designs that could be adapted to any terrain or climate, using modular components and construction techniques that minimized the need for specialized skills or materials. American factories began producing extraordinary quantities of specialized construction equipment, including bulldozers, graders, scrapers, and rollers that could move earth and prepare surfaces faster than hundreds of workers with hand tools. Perhaps most importantly, American industry developed innovative materials specifically designed for rapid airfield construction, including various types of metal matting that could be laid directly on prepared earth to create instant runways capable of supporting heavy bombers without requiring concrete or asphalt surfaces that took weeks to cure properly. The most famous of these materials became known as pierced steel planking, or PSP, which consisted of interlocking metal plates with holes punched through them to reduce weight while maintaining strength that could be laid down by small crews in remarkably short periods to create functional runways, taxiways, and parking areas. American engineers also developed rapid mixing concrete that could achieve usable strength in a fraction of the time required by traditional formulations and portable asphalt plants that could be set up near construction sites to eliminate transportation delays and produce hot mix material as needed throughout the building process. The combination of innovative materials, specialized equipment, standardized designs, and the American philosophy of getting the job done quickly rather than perfectly created a construction capability that would soon shock the world, and particularly shock German engineers, who had been trained to believe that proper airfield construction required careful deliberation and could never be rushed without compromising quality and safety. Creating revolutionary construction techniques and materials was only part of the solution, because the Allies also needed to train thousands of men to use these new methods and deploy them effectively across multiple theaters of war simultaneously. The United States established extensive training programs for construction battalions, teaching soldiers and sailors not just how to operate equipment, but how to think differently about construction challenges and overcome obstacles through creativity and determination, rather than giving up when conditions were not ideal. American construction training emphasized practical problem solving over theoretical perfection and taught men to make do with available materials and adapt plans to local conditions, rather than waiting for perfect circumstances that might never arrive in combat situations. British Royal Engineers similarly developed intensive training programs that combined traditional engineering knowledge with the new rapid construction techniques that had been developed during the Battle of Britain and refined through years of wartime experience. These training programs created a culture of can-do attitude among Allied construction forces, where engineers and construction workers saw obstacles as challenges to overcome rather than reasons why something could not be done quickly. The men learned to work in teams, with each person understanding their role in a larger coordinated effort where speed depended on everyone performing their tasks efficiently and moving to the next phase without unnecessary delays. They practiced building airfields in training areas under simulated combat conditions, including working at night under blackout restrictions, dealing with damaged equipment, and adapting to sudden changes in plans or available resources. This training proved invaluable when these men deployed to combat zones, where they would face real enemy action, difficult terrain, extreme weather, and the constant pressure of commanders demanding functional airfields faster than anyone had thought possible before the war began. The Allies also developed specialized units focused entirely on airfield construction and repair, rather than treating it as one task among many for general engineering units, which allowed for greater expertise and efficiency through constant practice and refinement of techniques. By 1943, the Allies had created a true construction force that combined innovative technology with highly trained, motivated personnel who understood that their work directly impacted the success of air operations, and potentially the outcome of entire campaigns, making every hour saved in construction time a contribution to ultimate victory over the Axis powers. The first major opportunity for Allied rapid airfield construction techniques to prove themselves in large-scale combat operations came during the North African Campaign, where British and American forces fought German and Italian armies across thousands of miles of desert terrain. The western desert of Egypt and Libya provided unique challenges for airfield construction, including loose sand, extreme temperatures, lack of water and vegetation, and the constant threat of sandstorms that could bury equipment and destroy inadequately prepared surfaces. British forces had been developing desert airfield construction techniques since 1940, when they first began operations against Italian forces in Libya, and they discovered that traditional concrete runways were often unnecessary in the hard-packed desert, where properly prepared earth surfaces could support heavy aircraft if correctly graded and compacted. The arrival of American forces in North Africa in late 1942 through Operation Torch brought new materials and techniques, including the first combat use of pierced steel, planking on a large scale, to create runways that could withstand the traffic of bombers and fighters, without requiring concrete or the time-consuming process of mixing and curing asphalt in desert heat. Allied engineers discovered they could prepare a basic airfield site in the desert in as little as 24 to 48 hours, by using bulldozers to clear and level the ground followed by graders to create proper drainage and crown on runway surfaces, then laying PSB, or simply compacting the natural surface, if soil conditions were favorable. This speed proved decisive as Allied forces advanced westward across Libya and Tunisia, because airfields could be established close behind the advancing front lines, providing air support and logistics capabilities that kept pace with ground operations rather than lagging weeks behind, as would have been the case with traditional construction methods. German forces, watching this rapid airfield construction from their defensive positions, found it almost impossible to believe that what they were seeing was real, because their own engineers had told them repeatedly that proper airfield construction required far more time than the Allies were taking. German prisoners captured during the North African campaign reported their amazement to interrogators when shown photographs and evidence of Allied construction speed, with many insisting that the airfields must have been prepared in advance, or that the photographs were propaganda, rather than accepting that their engineering doctrine might be incorrect. The success of rapid airfield construction in North Africa provided valuable lessons and confidence for even larger operations to come in Europe, where the Allies would need to build hundreds of airfields to support the liberation of the continent from Nazi occupation. As Allied planners prepared for the eventual invasion of Nazi-occupied Europe, they recognized that airfield construction would be absolutely critical to the success of the operation, because air superiority over the invasion beaches and beyond would require forward airfields that could support fighters and fighter-bombers operating over France and Germany. The planning for Operation Overlord, the code name for the Normandy invasion, included detailed provisions for rapid airfield construction immediately following the establishment of the beachhead, with specialized aviation engineer battalions assigned to land in the early waves specifically to begin airfield construction, while combat was still raging nearby. Allied planners knew from experience in North Africa and Italy that German forces would systematically destroy or damage existing airfields as they retreated, and that captured enemy airfields would likely be unusable due to cratering demolition and booby traps requiring either extensive repair or completely new construction. The solution was to plan for building numerous new airfields from scratch, using the rapid construction techniques that had been developed and refined over years of combat experience, combined with new innovations specifically designed for the challenging conditions of northern France, where soil drainage and weather would be far different from Mediterranean or desert environments. British engineers developed specifications for advanced landing grounds, which were temporary tactical airfields designed to be built quickly with minimal preparation using either PSB or a British innovation called square mesh track, which was similar to American steel planking, but used a different design that some engineers preferred for certain soil conditions. The plan called for constructing dozens of these advanced landing grounds across Normandy and Brittany in the weeks following the invasion, with each airfield capable of supporting a squadron or more of fighters or fighter bombers operating in direct support of ground forces pushing inland from the beaches. American engineering units prepared detailed equipment lists and material stockpiles that would be needed for this massive construction effort, including thousands of tons of steel, matting countless pieces of construction equipment, fuel for the machines, and all the other supplies required to build complete airfields, including not just runways, but also taxiways, parking areas, fuel storage tents for personnel, and all the other infrastructure needed for air operations. The planning also included provisions for specialized units that would land on the beaches and immediately begin clearing and preparing sites for airfield construction, even before the beachhead was fully secured, demonstrating the absolute priority that Allied commanders placed on establishing air power ashore as quickly as possible. This meticulous planning, combined with years of experience and training, would soon create a display of construction capability that would leave German engineers and commanders absolutely stunned when they saw it unfold across the French countryside in the summer of 1944. When Allied forces stormed ashore on the beaches of Normandy on the 6th of June 1944, the airfield construction units were not far behind, with some engineers landing on the first day of the invasion, ready to begin their crucial work. Within days of the initial landings, even while German forces were still launching fierce counterattacks, attempting to drive the Allies back into the sea, American and British engineers were already surveying sites and beginning construction of the first advanced landing grounds that would support tactical air operations. The speed of this construction was absolutely breathtaking, even to Allied observers who had seen rapid airfield building in other theaters, because the urgency of the Normandy situation and the experience gained from years of practice combined to produce results that seemed almost magical. One of the first American airfields completed in Normandy was constructed in just 9 days from initial clearing to operational status, with fighters landing and taking off to support ground forces who were still fighting to expand the beachhead. British engineers working on their designated advanced landing grounds achieved similar speeds, with some fields becoming operational in less than a week despite challenging weather conditions, including rain that turned Norman soil into thick mud that threatened to bog down equipment and delay work. The construction process involved massive amounts of earth moving as bulldozers and scrapers cleared hedgerows and filled in low spots to create level surfaces for runways. Then, graders shaped the runways to proper specifications, with crowns for drainage and smooth surfaces for aircraft operations. Teams of workers then laid thousands of tons of steel matting piece by piece like an enormous jigsaw puzzle, with each section interlocking with its neighbors to create a continuous surface that could support the weight of fully loaded fighters taking off for combat missions. Other crews simultaneously prepared parking areas, taxiways, and dispersal points, where aircraft could be spread out to minimize damage from any German air attacks that might penetrate Allied air defenses, while additional teams erected tents, installed fuel systems, and set up all the other facilities needed for round-the-clock air operations. German forces, observing this construction activity from their defensive positions inland, could hardly believe what they were seeing because, according to everything they had been taught about military engineering, what the Allies were accomplishing should have been impossible. German commanders receiving reports from reconnaissance flights and forward observers about new Allied airfields appearing almost overnight in areas that had been empty fields just days earlier, initially suspected the reports were exaggerated or mistaken, because their own engineering officers insisted that proper airfield construction required far more time than was being reported. When German prisoners were brought to Allied interrogation centers and saw the advanced landing grounds with their own eyes, many refused to accept that these were newly constructed facilities, insisting instead that they must have been built before the invasion, and somehow hidden from German reconnaissance, which of course was not true, but seemed more believable to them than accepting that everything they knew about construction was wrong. Understanding why German engineers found Allied airfield construction so unbelievable requires a deeper look at the specific technologies and materials that made such speed possible, because it was not simply a matter of working harder or faster, but rather represented a fundamental revolution in construction methodology. Pierced steel planking, which became the most iconic symbol of Allied rapid airfield construction, was a deceptively simple innovation that solved multiple problems simultaneously through clever engineering and mass production capabilities. Each PSB section was approximately 10 feet long and 15 inches wide, made of pressed steel, with hundreds of holes punched through the surface to reduce weight while maintaining structural strength, and featuring interlocking edges that allowed sections to be joined together without welding or bolts, simply by overlapping and pressing together. The holes served multiple purposes beyond weight reduction, including allowing water to drain through the surface, rather than pooling on top, preventing the matting from acting as a sail that wind could lift and tear away, and reducing the amount of steel required per section, which was critical given the enormous quantities needed for airfield construction worldwide. A team of just a few dozen men could lay hundreds of sections per hour once they developed rhythm and coordination, rolling out the matting like an enormous metal carpet across prepared Earth surfaces to create instant runways that could handle combat aircraft immediately without any curring time or additional preparation. The steel had enough flexibility to conform to minor irregularities in the ground surface, while being strong enough to support repeated landings and takeoffs by aircraft weighing many tons, including heavy bombers, when double layers of matting were used for extra strength. American factories produced PSB in staggering quantities, with millions of sections manufactured and shipped to every theater of war, representing a triumph of industrial capacity that few nations could match, and Germany certainly could not duplicate, while fighting a multi-front war against opponents with larger populations and resources. British square mesh track used a similar concept, but featured a grid pattern of steel bars welded together rather than punched holes in solid sheets, which some engineers preferred, because it provided better traction for aircraft tires and slightly better drainage, though it was heavier and required more steel per section. Beyond matting materials, the Allies also employed rapid-setting concrete formulations that could achieve load-bearing strength in hours rather than days, allowing runways to be built with permanent materials when steel matting was unavailable, or when conditions required more durable surfaces for sustained heavy use. Portable asphalt plants that could be transported by truck or ship and set up at construction sites provided hot-mix asphalt on demand, eliminating the delays associated with transporting material from distant permanent plants, and allowing paving operations to proceed continuously without waiting for deliveries. Heavy construction equipment, including the latest bulldozers, scrapers, and graders, gave Allied engineers earth-moving capabilities that far exceeded anything available to German forces, who relied more heavily on manual labor, supplemented by smaller machines that could not match American equipment for speed or efficiency in preparing airfield sites. While technology and materials were essential components of Allied airfield construction success, the human element was equally important, because even the best equipment and materials could not achieve remarkable results without skilled, motivated people who understood their mission and worked together effectively under difficult conditions. The men of the aviation engineer battalions and construction units came from diverse backgrounds, including professional contractors and construction workers, who had built roads and buildings in civilian life, farmers, who understood earth and drainage mechanics, equipment operators, who could make machines perform seemingly impossible tasks, and young men with no construction experience, who learned quickly under the pressure of wartime necessity. These units developed a fierce pride in their work and engaged in friendly competition with each other to see who could complete airfields faster or overcome more difficult obstacles, with stories of construction achievements, passing through the ranks and inspiring others to push even harder on their own projects. The officers and senior non-commissioned officers who led these units understood that speed came not from simply working faster, but from better organization, careful planning, elimination of wasted effort, and maintaining morale, even when conditions were miserable and the work was exhausting. They learned to anticipate problems before they occurred and have solutions ready rather than stopping work, while figuring out what to do about unexpected obstacles that inevitably arose during any construction project. The culture of these units emphasized improvisation and creative problem-solving, with men encouraged to suggest better methods or shortcuts that could save time without compromising essential quality standards for aircraft operations. Workers understood that every hour saved in airfield construction meant fighters could get into the air sooner to protect ground forces, and that bombers could strike enemy targets more frequently, which made their labor feel directly connected to combat success and gave meaning to work that was often physically brutal and performed under dangerous conditions. Many construction sites were within range of German artillery, and some came under air attack while work was ongoing. But the construction crews continued working through alerts and attacks whenever possible, because they knew that stopping work meant delaying air operations that could save lives on the front lines. This dedication and sense of purpose was something that could not be captured in technical manuals or equipment specifications, but it was absolutely essential to achieving the speeds that so astonished German observers, who saw only the results without understanding the human determination and sacrifice behind them. The Allied construction forces also benefited from excellent logistics and supply systems that kept construction sites supplied with materials, equipment, fuel, and spare parts without the interruptions that plagued German operations, as Allied air superiority and naval dominance strangled Axis supply lines in every theater. When equipment broke down, replacement parts arrived quickly, and if machines were damaged beyond repair, new equipment could usually be obtained within days, rather than weeks or months, keeping construction projects moving forward, without the lengthy delays that German engineers had come to expect as normal in wartime conditions. German military engineers and commanders struggled to comprehend how the Allies were achieving construction speeds that violated every principle they had been taught in their training, and that contradicted their extensive practical experience building military infrastructure across occupied Europe. Initial reports of Allied airfields being built in days rather than weeks were dismissed as exaggerations or intelligence errors by German higher headquarters, who could not reconcile such claims with their understanding of construction realities. As more reports arrived from multiple sources, including aerial reconnaissance forward observers and interrogated Allied prisoners, the evidence became impossible to dismiss, but German engineers still searched for alternative explanations, rather than accepting that Allied construction methodology was fundamentally superior to their own approaches. Some German officers theorized that the Allies must have prefabricated entire airfields in Britain and somehow transported them across the English Channel in sections to be assembled rapidly in France, which seemed more plausible than believing that actual construction could happen so quickly. Others suggested that Allied airfields must be temporary expedient facilities of such poor quality that they would fail quickly under operational use, and therefore did not represent real construction achievements comparable to proper German engineering standards. When German engineers finally had opportunities to examine captured Allied airfield materials, including PSB and square mesh track, after successful counterattacks, temporarily recaptured some areas, they were forced to admit that the materials were cleverly designed and fit for purpose, even if they did not meet German standards for permanent installations. The fundamental problem was that German military doctrine and engineering philosophy had no framework for understanding that temporary adequate solutions might be strategically superior to permanent excellent solutions, when speed was the critical factor in military operations. German training emphasized doing things correctly according to established standards, even if it took longer, because poorly executed work would create problems later that would consume more time and resources to fix than if the job had been done properly initially. This philosophy made perfect sense in peacetime or in situations where time was not critical, but it became a serious disadvantage when facing an enemy who had learned to value speed over perfection, and who possessed the industrial capacity and innovative spirit to make speed feasible through new materials and methods. Some younger German engineers who saw Allied construction methods firsthand expressed admiration for the cleverness and practicality of the approaches, even while remaining loyal to their own nation, and some even suggested that German forces should adopt similar methods for their own construction needs. However, the German military bureaucracy and industrial system lacked the flexibility and resources to make such changes, even if commanders had been willing to abandon traditional methods, because Germany was already struggling to produce enough basic weapons and ammunition to continue fighting on multiple fronts, and could not spare industrial capacity for developing new construction materials or manufacturing specialized equipment in quantities comparable to American production. The rapid construction of airfields across France following the Normandy invasion enabled the Allies to bring overwhelming air power to bear against German forces in ways that would have been impossible with traditional slower construction methods that left air units dependent on distant bases in England. Fighter bombers operating from advanced landing grounds in Normandy could reach targets across northern France with full bomb loads and adequate fuel for extended combat, while remaining on station longer to support ground forces during critical battles. As Allied armies broke out of the Normandy beachhead and began racing across France toward the German border in August 1944, the airfield construction units moved right behind them, establishing new bases every few days to keep tactical air power close to the rapidly moving front lines. This mobility of air power gave Allied ground commanders a level of air support that German forces could never match, because the Luftwaffe was increasingly forced to operate from bases deep inside Germany or distant areas of occupied territory, due to the loss of forward airfields and the danger of operating from fields within range of Allied ground forces. The construction teams became expert at identifying suitable locations for airfields during rapid advances, using aerial reconnaissance and advance parties to select sites, then moving in with convoys of equipment and materials to begin construction, sometimes within hours of German forces withdrawing from an area. In some cases, Allied engineers were building airfields so close behind advancing armies that German artillery could still reach the construction sites, requiring work to continue under fire or pause during particularly heavy shelling, then resume as soon as the threat passed. The speed and efficiency of these construction efforts meant that, by the fall of 1944, the Allies had established a network of tactical airfields across France-Belgium and parts of the Netherlands that provided coverage for continued operations toward Germany itself, with new fields being added and old ones expanded or improved as the military situation evolved. German forces attempting to counterattack or slow the Allied advance found themselves facing airstrikes from multiple directions, launched from airfields that had not existed days earlier, creating a sense of futility among German soldiers who felt they were fighting an enemy with unlimited resources and supernatural construction abilities. The psychological impact of rapid airfield construction went beyond the immediate tactical advantages because German troops could see with their own eyes that the Allies possessed organizational and technological capabilities that Germany could not match, which contributed to declining morale and increasing doubts about ultimate victory, even among soldiers who remained willing to fight for their homeland. While rapid airfield construction in Europe was impressive, the challenges faced by Allied engineers in the Pacific theater were even more extreme, and the solutions they developed were equally remarkable, though less well known than the European achievements. Islands across the Pacific offered terrain and conditions far different from European battlefields, including dense jungles, volcanic rock, coral atolls, with minimal soil-dense vegetation that had to be cleared, heavy rainfall that turned everything to mud, and extreme heat and humidity that made physical labor exhausting and damaged equipment faster than normal. American Marine and Navy construction battalions, known as Seabees, became legendary for their ability to build airfields in the Pacific under conditions that seemed impossible, with some of the most famous examples including airfields carved from jungle and volcanic rock on islands like Guadalcanal, Bougainville, and the Philippines. The Seabees used the same rapid construction techniques and materials that were employed in Europe, including PSB and heavy equipment, but adapted them to Pacific conditions with innovations like coral surfacing for runways where suitable soil was not available for compaction. Coral proved to be an excellent runway material when properly crushed and graded, because it compacted well, drained effectively, and was available in abundance on many Pacific islands, requiring engineers to establish rock crushing operations as part of their construction efforts. The speed of airfield construction in the Pacific was often even more critical than in Europe, because islands captured from Japanese forces needed to become operational airbases as quickly as possible to support the next phase of island-hopping campaigns that moved American forces progressively closer to Japan. In some cases, Seabees came ashore during amphibious assaults and began construction work, while combat was still ongoing in other parts of the island, accepting the risks of working under fire, because commanders needed airfields operational within days to provide air cover and logistics support. Japanese engineers, watching American construction activities from defensive positions or through reconnaissance, were equally astonished as their German counterparts at the speed and scale of American construction capabilities, which seemed to violate everything Japanese engineers understood about construction requirements and timelines. The Japanese military had spent years building fortified positions and airfields across their Pacific empire, using traditional construction methods that required extensive time and labor, and they could not comprehend how American forces could build comparable or superior facilities in a fraction of the time. Some Japanese commanders initially dismissed reports of rapid American airfield construction as impossible exaggerations, until they saw the evidence firsthand or received confirmation from multiple independent sources that forced them to accept that American engineering capabilities were far beyond anything Japan could match. The disparity in construction speed contributed to Japan's ultimate defeat, because American forces could advance across the Pacific, establishing air superiority at each step, while Japanese forces lost airfields faster than they could build new ones, and increasingly found themselves without adequate air cover or logistics support. One of the keys to Allied success in rapid airfield construction was the extensive use of standardization, which allowed materials, equipment, and construction methods to be used interchangeably across all theaters of war without requiring custom solutions for each location. American and British engineers developed standard airfield designs with predetermined dimensions, layout patterns, and material requirements that could be adapted to local conditions, without requiring extensive redesign or specialized components. This standardization meant that construction units training in the United States or Britain were learning methods and practicing with materials that would be exactly the same when they deployed to combat zones, eliminating the learning curve that would have existed if each theater used different approaches. Equipment operators trained on specific models of bulldozers or graders could be confident that they would find the same machines in overseas theaters, and spare parts supply systems could be simplified because fewer different types of equipment meant smaller inventories of parts needed to keep machines running. Pierced steel planking and other matting materials were standardized in dimensions and connection methods, allowing sections manufactured in different factories or at different times to be used together without compatibility issues that would have created delays and complications. Even seemingly minor details like the size of fuel drums, the capacity of water trailers, and the dimensions of tents and temporary buildings were standardized across Allied forces, allowing logistics personnel to ship materials without worrying about whether they would fit local requirements or work with equipment already in theater. This standardization also facilitated the mass production methods that gave the Allies their overwhelming material advantages, because factories could produce enormous quantities of identical items, knowing that everything manufactured would be usable somewhere in the global war effort rather than risking producing materials that might not fit specific local needs. German forces, by contrast, often struggled with lack of standardization, as different branches of the military used different equipment specifications and materials that were not interchangeable even within Germany, let alone across the various Axis partners who each maintained their own standards and specifications. This lack of standardization complicated German logistics and slowed German construction efforts, because engineers might find themselves with materials that did not fit their needs or equipment that required parts that were not available locally, forcing improvisation and workarounds that consumed time and reduced efficiency. The Allied commitment to standardization represented a philosophical difference in approach to warfare, where American and British planners emphasized the advantages of simplicity and interchangeability over the theoretical benefits of customization and optimization that German engineering culture preferred, but could not effectively implement under wartime conditions. The rapid airfield construction techniques developed during World War II had impacts far beyond the immediate military applications that won the war, because they fundamentally changed how the world thought about aviation infrastructure and what was possible in construction timelines. After the war ended, the materials and methods that had been created for military airfield construction found civilian applications in the expansion of commercial aviation, as nations rebuilt destroyed infrastructure and created new airports to serve growing passenger and cargo traffic. Pierced steel planking and similar matting materials were used for temporary roads, parking areas, and work platforms in construction projects around the world, with surplus military stockpiles finding new life in civilian applications for decades after the war ended. The heavy construction equipment that had been developed or improved for military airfield construction became the foundation for the modern earth-moving industry, with companies like Caterpillar transitioning from wartime production to civilian markets, using lessons learned from military applications to improve their machines. The organizational methods and management techniques that allowed Allied engineers to coordinate massive construction projects and complete them at unprecedented speeds influenced the development of modern construction project management and helped establish new standards for what could be achieved with proper planning and execution. Veterans who had served in construction battalions and engineering units during the war brought their experiences back to civilian life and became leaders in the construction industry, applying the lessons they learned about speed efficiency and problem solving to peacetime projects that built the infrastructure of the modern world. The confidence that came from seeing seemingly impossible construction challenges overcome during the war inspired engineers and builders to attempt projects that previous generations might have considered too difficult or time-consuming, leading to ambitious infrastructure programs that reshaped landscapes and connected communities. The contrast between Allied and German approaches to airfield construction also provided important lessons about the dangers of rigid adherence to doctrine and the importance of innovation and adaptability in military operations, with post-war military education emphasizing the need to remain flexible and willing to adopt new methods even when they contradicted established practices. The story of rapid airfield construction became part of the narrative of how industrial democracies defeated totalitarian regimes through superior organization, logistics, and innovation, rather than simply through greater numbers or braver soldiers, though those factors certainly played important roles as well. Modern military forces around the world continue to use variations of the rapid airfield construction methods developed during World War II with updated materials and equipment, but following the same basic principles of speed standardization and efficiency that proved so effective 8 decades ago. Looking back across the decades since World War II ended, it becomes clear that rapid airfield construction represented more than just a technical achievement, but rather embodied a fundamentally different philosophy of engineering and military operations that gave the Allies decisive advantages in numerous situations. The German approach to airfield construction emphasized permanence quality and adherence to established standards, which made perfect sense in peacetime, or in stable situations where facilities would be used for extended periods, but became a liability when facing enemies who moved faster and adapted more quickly to changing circumstances. The Allied willingness to accept temporary adequate solutions rather than insisting on permanent perfect ones reflected a pragmatic understanding that winning the war required being fast enough to seize and exploit opportunities rather than being thorough enough to satisfy engineering textbooks. This philosophical difference extended beyond airfield construction to many aspects of the war effort, including weapons production, where American factories churned out enormous quantities of good enough tanks and aircraft, rather than smaller numbers of technically superior but more complex German designs that required more time and skilled labor to manufacture. The Soviet Union followed similar principles on the Eastern Front, producing simple, reliable weapons and equipment in staggering quantities that overwhelmed German forces despite often being individually inferior to German counterparts in technical specifications. The Allies understood that time was a form of military power, just as important as firepower or armor, and that speed of deployment and construction could be more valuable than perfection of design or execution when circumstances demanded rapid action. German engineers and commanders struggled with this concept because their training and military culture emphasized excellence and thoroughness as fundamental virtues that should never be compromised even when compromise might serve larger strategic objectives. The cognitive dissonance experienced by German engineers watching Allied airfield construction reflected this deeper philosophical divide between two different ways of thinking about warfare and engineering, with the Allied approach ultimately proving more effective in the specific circumstances of World War II. This does not mean that German engineering was inferior in all respects, because German weapons and equipment were often technically excellent, and German soldiers fought with great skill and courage throughout the war, but rather that German military culture had not adapted to the realities of industrial total war, where material production and logistical efficiency could matter as much or more than battlefield tactics or weapon quality. The lesson that speed and adaptability could be more important than perfection remains relevant today, as military forces grapple with rapidly changing technologies and operational environments that reward innovation and quick response over adherence to established doctrine. Behind the statistics and technical achievements of Allied airfield construction were countless individual stories of men who performed extraordinary work under difficult, dangerous conditions far from home, with little recognition or glory, compared to combat soldiers who received medals and headlines. Construction workers and engineers who built airfields in Normandy under German artillery fire showed courage equal to any infantryman, but their contributions were rarely celebrated in newspapers or official histories, because construction work seemed less dramatic than combat even when it was performed under fire. Seabees who carved airfields from Pacific jungles while fighting disease, insects, and occasional Japanese attacks endured conditions that were miserable beyond description, but they kept working because they understood their mission was essential to victory, even if their names would never be famous. African-American construction battalions, who built many of the airfields and performed much of the heavy labor in segregated units, contributed enormously to Allied success, despite facing discrimination and limited recognition during and after the war, with their achievements only beginning to receive appropriate acknowledgement in recent decades. The officers and engineers who planned construction operations and solved countless technical problems on the fly demonstrated creativity and leadership that saved weeks of time on projects throughout the war. But their problem-solving rarely made it into official reports, because successful solutions seemed routine once implemented, even when they required genuine innovation. Equipment operators who kept bulldozers and other machines running under terrible conditions through skill and determination enabled construction speeds that would have been impossible with less capable maintenance and operation, often nursing badly damaged equipment through completion of critical projects before allowing themselves to stop for proper repairs. Supply personnel who ensured that construction sites received necessary materials on time, despite the chaos of combat operations and limited transportation resources, enabled construction units to maintain their remarkable pace without interruptions that would have resulted from material shortages. Medics and support staff who kept construction workers healthy and functional, despite the physical demands of the work and the diseases and dangers present in combat zones, contributed to construction success by minimizing the time lost to illness and injury. All these individuals and countless others whose names and contributions have been forgotten were essential parts of the larger achievement that so amazed German engineers, because rapid airfield construction was never about individual heroics, but rather about thousands of people working together, effectively toward common goals, with each person doing their part to create results that exceeded what anyone thought possible before the war began. The story of how Allied forces built airfields at speeds that German engineers could not believe possible is ultimately a story about innovation, adaptation, and the power of challenging established wisdom when circumstances demand new approaches to old problems. When Britain stood alone against Nazi Germany in 1940, necessity forced British engineers to abandon traditional construction methods and develop faster techniques, because survival depended on keeping aircraft flying from whatever airfields could be made operational quickly enough to matter. When American industrial might and engineering creativity joined the Allied cause, those early British innovations combined with American mass production and organizational capabilities to create construction systems that revolutionized military airfield building and shocked enemies who had believed such speeds were impossible. The thousands of men who built these airfields across Europe, the Pacific, and other theaters demonstrated that human determination combined with innovative technology and effective organization could achieve results that seemed miraculous to observers, who did not understand the methods and materials that made such speed feasible. German engineers and commanders who witnessed Allied construction capabilities eventually had to admit that their own approaches were inadequate for the demands of modern mobile warfare. But by the time they reached this realization, it was too late to close the gap, because the Allies had already established overwhelming advantages in air power logistics and operational tempo that German forces could not overcome. The legacy of rapid airfield construction extends far beyond World War II itself, because the techniques, materials, and philosophies developed during those desperate years influenced post-war construction industries and military engineering doctrine in ways that continue to shape how modern societies build infrastructure and respond to urgent needs. The contrast between doing things correctly according to established standards and doing things quickly enough to matter when speed is essential remains relevant today in both military and civilian contexts, as organizations struggle to balance quality with timeliness in environments where circumstances change rapidly and opportunities must be seized before they disappear. Perhaps the most important lesson from this remarkable chapter of engineering history is that innovation often comes from challenging the assumption that things must be done the way they have always been done, and that remarkable achievements become possible when creative people are given freedom to experiment with new approaches, and are supported by organizations willing to embrace change even when it contradicts traditional wisdom. The German engineers, who could not believe how quickly the Allies built airfields, were not foolish or incompetent, but rather were prisoners of their own training and doctrine that had not prepared them to imagine that construction could be fundamentally reimagined for new circumstances and purposes. In the end, the speed that seemed impossible to German observers became the reality that helped win World War II, proving once again that wars are won not just by brave soldiers and superior weapons, but by the engineers and workers who create the infrastructure and logistics that make sustained military operations possible, and that innovation in unglamorous fields like construction can be just as decisive as breakthroughs in weapons technology or battlefield tactics.